Hi there. This is going to be the ET370 lab videos. We're going to start off with our first lab on an introduction to Arduino. We're going to go over the basics of how to take in a button data, how to control an LED. We'll go over things like syntax, variables, functions, and pseudocode. And hopefully this is just a nice reference if you want to get started in Arduino and how to just get something simple to run. Okay, so let's just start with the basics here. We got our Arduino. This is the Uno, and there's many different variants, but this is kind of the most common basic one available. You can see here you have a USB port, so if you want to use this in real life, I'll be going over Tinkercad, which actually shows a virtual version. You'll plug into the USB port into your computer. You have a nice reset button. You can externally power it through a jack if you want to remotely power it, and then you wouldn't have to use the USB. And what you want to see on the side is all these digital pins, right? These are going to be useful pins to be able to interact with the world. On the right here, these digital pins are inputs and outputs, which are nice. And some of them will have special functions, like you can see this PWM. And this PWM stands for pulse width modulation. It allows you to synthetically create an analog type of signal out. Now, if you look over here on the lower left, you'll see analog pins, and these are actually analog in pins, which means you can sense something, so reading things, right? And then on the upper left here, you see things like ground and 3.3 and 5-volt power. These are all very useful for providing a reference and also power to sensors and low power actuators. The last thing you'll see is this VIN pin here in this power jack. They are kind of similar in that you can power up the Arduino with 7 to 12 volts, and you can use a battery or some external AC to DC converter to do so. But this is nice. But this is it. The Arduino is this black chip, the Atmel processor here, and it's a very versatile, versatile microcontroller, and well loved by the open source community. And so we'll be using it here. Okay, so here is the basic input and output table or graph that I made. And what I want you to notice here on the right, we have digital, and on the left, we have analog, and on the upper part, the upper half, we have input and output. And so what does that mean? Let's say you are the Arduino and you want to take in digital data. Well, if you want to take in digital data, you're going to be in this first quadrant. And you would use the syntax digital read of some pin number. And so that could be pin 10, pin 7, so on and so forth. And what it would do is it would give you a high or low answer. And so, for example, if the voltage coming into this pin 10 is high, this would give you a 1 or a high value for this state variable. Okay. Now, let's say you want to send out, like you want to control an LED. If you want to control an LED, then now you want to use something like digital write. Okay, so notice it's the same format, digital, but read versus write here. And now I got to tell it which pin I'm going to send out and the value, right? Notice the slight difference in syntax. And this is high or low. Now, if you ever forget the exact syntax, you can always go to Google, type in Arduino, and look up the common commands, and the information will be broken out for you. Okay, on the analog side, which we will get into the next week's lab, this is a way to read in analog data. So if you want to read in like the value from a potentiometer, you could use analog read. Again, look at the same format. You're telling it which pin to use, and in this case, it's going to be A0 to A5. But the difference is that the value is not high or low anymore. It's going to be 0 to 1023. Okay, and 1023 seems like an odd number, but it's actually related to an integer number of bits. And so I believe 2 to the 10 bits is going to be 1023. Okay. What do we have here? Analog write. Now, similar to digital write, you got to tell it the pin and a value, and you're no longer telling it high or low. You're telling it a value between 0 and some max number, in this case is 255. And so what pins would you use? You would actually use these PWM pins. And actually next week, we'll go into that. And 255 corresponds to 8-bit. And you might have heard about 8-bit in video games, okay? All right, so let's focus on this right half, this digital. So we are going to control an LED, and we are going to read in a button in this, this video, okay? So these are the four main ways. Now there's more ways, there's interrupts and stuff like that, but these are the four main ways we're going to take in and send out data from the Arduino. Okay, so let's look at the Arduino interface. So you can go to the arduino.com and you can install Arduino, and what you get is this interface right here. Okay, right now I have the Blink program up, but you can see this arrow. This is how you would upload your program to your Arduino, and you have to make sure that your COM port here, so there's a port, your Arduino actually links up to the correct COM port. Okay, so when you plug in Arduino, it'll actually, your computer is smart these days, it'll recognize which port your Arduino is plugged in. You got to make sure to select that. It doesn't automatically know to select that. The other thing you got to make sure is to select the correct board. So right now I've been using a Teensy for fun, but it'll pop up with the ability to figure out, well, are you going to use a Uno or a Leonardo or all the different types of flavors of Arduino, okay? This here is the serial monitor. This allows you to stream data. So you could actually print out data from the Arduino, it'll pass it along the USB and it'll stream it out to the serial monitor. Okay, so this is just the rough interface. Now, like I said, we're going to use this program called Tinkercad. So please sign up for Tinkercad. Once you sign in, you have the ability to go to circuits, and we will get to play with a new Arduino breadboard virtually, which is kind of cool. And that's how we'll focus this lab. Okay, but this is the main kind of dashboard interface for Tinkercad, and you can see I have a bunch of the labs, your future labs already built out. But if you want to create a new circuit, you go hit this green button, create new circuit, and let's see here. I'm going to let that load. And you can go over here and just go to Arduino. So look at the start as Arduino, and then just load up, let's say breadboard, just bring that in. Give it a minute. I think yep, there we go. Perfect. Okay, so this is representing the physical system, which is really cool. And the nice thing, if I hit code, this code here, you got to make sure you're on text. Continue, yes. Notice this code is actually already preloaded with Blink, which should match what we have here. Notice we have 13, pin mode, all this stuff here, okay? Good, let's go back to the document here. Okay, so what we're gonna be doing is we are gonna be driving an LED. So let me maximize this. And just a short review for an LED. LED is essentially a diode that lights up, and you have the longer lead here, which is the anode. That's the side that if you put high voltage, it will allow current to flow. If you put high voltage on the cathode side, it'll block the current, no current will flow, okay? So we'll be using a diode to light up, and we'll be using our command, our new friend, digital write, okay? Here's a breadboard, and just in case you forgot, this is how a breadboard is connected. The rows are all shorted together, and these columns are shorted together, right? These are typically your bus, your power and ground bus. Now, good practice, ladies and gentlemen, please use the ground and blue, and then 5 volts or 3.3 volts or power for this red or this positive. I know in previous labs, some of the students flip it, and it just adds confusion, right? If I'm helping in troubleshooting, try to stay with this convention of blue is ground and red is power, okay? All right, let's keep going. All right, so in this first program, we're gonna look at Blink, right? And what I'd like you to think about before you even start writing code at this early stage of your programming careers is to write what we call pseudocode or fake code. And it's a way of stating the algorithm or process without any specific syntax. So right now, Arduino is like a C++, watered down C++. Okay, so there's Java, there's Python, there's C, there's so many different programming languages out there. But what we want to do is we want to write a program in a fake way, so we don't care about the syntax. And so, for example, if I want to turn the LED on and off or blink the LED, this is my simple pseudocode. Turn it on, wait, turn it off, wait, repeat. Okay, that's it. That's turning, that's our blink. Okay. So now how would we get this to work? So let's look at our example. So the nice thing about Arduino, both in Tinkercad and in the regular Arduino program, is that it has preloaded examples, okay? All right, so how do you get to these examples? If I open up a new sketch here, So if I just open up a new blank sketch, let me get rid of this. And you had something like this, nothing in there. There's a setup and a loop. How would you get to a blink example? So you can go to File, Examples, Basics, Blink. Okay, File, Examples, Basics, Blink. All right. On the Tinkercad, what is it? Well, you already saw that we loaded this up and we already have it immediately in the code. But let's say you didn't have it. All you got to do is you're going to have both of these kind of side by side. You just copy and paste. Just grab this, Control C, and then you can just do a little Control V. Bang, it's there. Okay, so you got your blink. You got this guy here. Okay, let's keep going. What are we going to do with this? Well, what this is going to do is going to light up an LED. And so there should be an onboard LED, pin 13. Okay, so let's go look at the Tinkercad. Okay, because this has the same code as the real thing here. And there's an onboard LED right here. Okay, and so I should be able to just run this and see this work. So I'm going to hit start. Let's hope this works. Okay, fantastic. Notice right here, there's a little LED and that's lighting up. Okay, so I want to slowly walk through this code and just show you what's going on, because my assumption is you guys have either had very little or no programming. Okay, so we're going to start from the very top. If you notice, they're in different colors. It's kind of like in the regular Arduino, it's kind of gray, right? And in this Tinkercad, it's kind of orangey brown. What do you notice? Well, what I notice is that you see these slash and asterisk. This is called a comment. In fact, I like to call this a comment sandwich, right? And the way this works is that anything that's commented is for the human to read, not for the computer to understand. It's like notes to yourself or future self or other programmers what this program is doing. Notice it gives the title, it gives us the function of this program, and then you have some more comments here, okay? And what does this say? So these are a way to comment one-liner. So on line 8, you have just a double slash. So if you want to just do one line at a time, you do a double slash. If you want to comment a whole block, you can do this kind of comment sandwich, okay? And what is it saying? Pin 13 is it has an LED connected on most Arduino boards, and then it has some exceptions, right? Okay. And notice they have a variable here called int LED, and they say equal to 13. Now notice this is how we declare a variable. And let's parse this out. What is int? Int stands for integer, and I think you understand what integer is. 0, 1, 2, 3, 4, right? Those are integers, right? And then this is the name. It could be any name, but this is the name. And notice you can see that the name appears here on line 18, on line 23, and line 25. Same for this one, LED, 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 because this is a copy. Now you might go, wait, on my Arduino, I don't see these numbers here. Well, you can get those numbers up here, going File, Preferences, and Display Line Numbers. That might be very helpful for you guys, display those line numbers, right? Because then you can, when you're communicating and sharing this, you can say, oh, line 13, line 14, right? Okay. So what's next on here? So let's just go back to here. Int LED equals 13 semicolon. The semicolons are going to be so annoying, but it's just a necessary thing. This is how you tell the program, Arduino, that you're done, right? That you're done with that line. Okay. Do semicolons go everywhere? No, you don't have a semicolon here. You don't have a semicolon there. But on the majority of the lines, you have a semicolon, right? That's going to be a common mistake. Did you remember your semicolons everywhere? Okay. What is this equals? I want you to think of the equals as an assignment. It's assigning the right part into the left. So now this variable, think of it as a container that only takes integers. It is taking on the value of 13, okay? Okay, good. Then what do we have? We have this comment, okay? And then we have this thing called a setup, right? So void setup, parenthesis, parenthesis, curly bracket, curly bracket. Notice we have a curly bracket sandwich. Curly brackets are another painful thing that you're just gonna have to deal with, right? Curly brackets are just, they're hard to keep track of, but once you realize, you get good at accounting for the curly brackets, it's gonna make your life a lot easier. Okay, so notice this curly bracket at 16 ties into 19. Okay, so what does this next line do? It's a comment again, and it's initializing this LED, which is pin 13, which physically, if I go back to here, physically is this pin here, pin 13, or that onboard LED, okay, or this pin 13 here, right? It's physically that, and it's saying, I want you to be an output. And you might be thinking to yourself, well, could you make it an input? You sure can, right? You can make this input, and we could use the digital read. Right now we're using digital write because we are outputting information to the LED. Okay, so let's keep going here. So this stuff from lines 1 through 20 only executes once. You plug in the Arduino, you power it on, it starts at line 1, executes, ignore. Oh, I'm going to initialize this LED as 13. Oh, I'm going to set the pin as output. Okay, now we get to the special thing called the loop. All right, so all Arduino programs are going to have a setup and a loop. So this is kind of an overall structure. Now, what does the loop do, and why is it special? Oh, look, this comment has a nice description. It runs over and over again forever and ever, unless you tell it not to, okay? Or you turn off the power to the Arduino, or the heat death of the universe takes over. Okay, anyways, so line 23, what is it saying? Digital write. Oh, nice, that was on our quadrant, right? Digital write, in this case, LED is 13, and you're gonna tell it hi, which means turn the LED on. It's going to make that pin turn up to a high value of 5 volts, sometimes 3.3, depending on your Arduino, but 5 volts for the Uno. So that means this pin will actually show up as 5 volts, okay? And then what happens here? It's going to wait 1,000. Well, 1,000 watts. The delay function, notice it's in orange, the delay function is units of milliseconds. So 1,000 milliseconds is 1 second. And digital write, LED low, is going to turn off the LED, wait for 1 second. And what do we do here? We repeat, because we're at the bottom of the loop. We're going to go back to the top of the loop. Is that matching our pseudocode? So let's go back and double check our pseudocode. Pseudocode. Yes, turn on, wait, turn off, wait, repeat. Good, okay. So we are matching our pseudocode. You are seeing this work on the simulation here, okay. And so everything's hunky-dory. If we play with the delay value, what do you think is going to happen? Well, hopefully the rate of this blinking changes. So we're going to stop simulation. Let's play with it, maybe make it 200, something extreme, okay? And then I'm going to hit start again, and notice bang, 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 this blinks a lot faster, okay? All right, let's move on to the next part of this lab. So if we want to control an LED and we want to connect it to a different pin, we can do that. So we can connect it to pin 9 instead of pin 13. Okay, so we're going to install an LED with a 220 ohm, which is red, black, current limiting resistor. Now, the beautiful thing about Tinkercad is it automatically gives you the color code. Okay. All right, so we're going to have this simple schematic first. Yes, it would be good to draw this simple circuit diagram first. It's pretty darn easy. In fact, we could even draw it here. I'll use the annotation. Can I do it? What does it look like? Here's your Arduino. Here's pin 9. Here's a resistor. Here's a LED, and we go to ground. Beautiful annotation. I hope you can see that, right? Okay, good. So let me clear that annotation. Clear all drawings, good. Okay, so we are going to now connect this LED to pin 9. Let's see how to do that. So I'm going to go back to Tinkercad, okay, and I'm going to stop the simulation, and I'm going to close the code because we want to access some of our components. So we're going to go back to basics. Oh, look at this, a nice LED. So put this LED here, and we have a nice resistor. So I'm going to take this resistor, I'm going to rotate it sideways. So I can go over here, rotate it. And I'm going to put the LED resistor here. And I'm going to make this resistor 220 ohms. So look at this. I can go to ohms, type in 220. Okay, good. I got it. And notice it's red. Is it black or brown? I guess it's brown, but it's 220 ohms. Okay. And then I can first use the pin 13. So I can go pin 13. And I can go to here, okay? And then I can see, I can follow the path, boom, to here, here. And then I can go from the end of the LED back to ground. And notice this black line is connected to my ground, okay? All right, good. So if I run this program again, not only should the onboard LED blink, but also this LED should fire up, okay? And is it firing up? It is not firing up. Why is it not firing up? Let's see. Let's look at this closely. What do we have here? Is this? Oh, look at this. This is the cathode. This is the anode. Oh, that's why. Okay. So let's flip the orientation. Okay. So let's go here. I'm going to flip this to ground, and then I'm going to move this over. Bink. I'm going to move this over. Bink. Perfect. Okay. So let's start the simulation again. Yay. Look at that. The LED works. Fantastic. This is cool. I love this. So what do we have? We have a way of controlling the onboard LED of pin 13. It's doing the onboard and pin 13, but like I said in the lab, we want to now control it to pin 9. So I can now change this one variable to pin 9, okay? And now I can take this line here, instead of going to 13, just move it over to pin 9. Done. In fact, if I want to make this nice here, this is a little trick. I think this is actually better. Let's see if I can do this. Okay. Let's go to here and delete that. Oh, I think I got to close the code. Go here, do this, delete this, and I'm going to make this a little bit nicer. I'm going to move this over, and I'm going to go this way, this way, this way, this way. Oh, so much better. That just feels so much cleaner. Nice. Okay, so let's double check. 9 goes to the resistor, through the anode, cathode, ground. We're good. Code, start simulation. Yay. And look at that. Notice the onboard LED now no longer fires up, but now pin 9 does. Excellent. Okay, so I'm going to stop simulation here, and let's go to this. All right. So here you will modify your program to emit an SOS Morse code. First write the pseudocode, then modify the blink to emit an SOS. Make sure to have long space between the letters and extra short space between SOS. Copy and paste will be helpful. Now, I'm not going to do this for you guys in this lab. This is an assignment that I want you guys to do, but I will give you a little bit of a hint how you do that. Well, we know how to turn this on and off, right? So we know how to make one blink. Can you imagine if I did this 2 more times? So that's why I said copy and paste will help you. I have now created a ... Okay, so I can even put a comment here. This is my S. Okay, I could do the same thing, but I could do an O, and then I could do the same thing, and I could do an S. Can you imagine how by changing the delays, I'm going to create a longer on time, SO, like this will be ... and then I'll be dash, and then I'll do ... Okay, so I think at this point you have enough understanding to actually build your own SOS blink. So I'm going to let you do that. Okay. All right. We are going to move on. So pause the video, get your SOS working, and then come back to this video after you get it working. And I think we'll be good. Okay. So let's go back to here, the next one. All right, and so the next one here is saying, well, okay, so you brute force made an SOS, congratulations, okay? And what you should see when you run it is the light go ... dash, repeat ... okay, and so on. So then I want to introduce you to this thing called functions. So function is a segment of code that the programmer can call and execute and then return. It's like a subroutine, right? And it makes the code more reliable because you're reusing code. And so here's an example of how you would implement a function, right? So you're inside your loop, you'd call function, let's call the function XYZ, you could go do something else, and then you could call the function XYZ again, right? And so here's a simple function. Let me see if I can zoom out here, zoom out. Okay, so what does this do? Actually, we could code this up. What this is saying is doing our blink function, but look, we've made a function out of blink, and we've given it a parameter called delay time. So we have functionalized blink, and look at this delay time is now a variable in here. Okay, you see that? So in your loop, the first time it runs blink, it turns the LED on and off at 1 second intervals. And then it goes in here and it turns the LED on and off at ½ second intervals and then repeats. 1 second intervals, ½ second intervals, 1 second intervals, ½ second intervals. Let's see if we can just code this up real quick and see this working. Okay, so I'm going to go over here and I'm going to bump this over, put this here, good, and close these out. And let's just copy this, okay, delete here. I don't need to do this, so I'm going to delete this. And I'm going to take this guy. I'm just going to literally copy void blink function int delay time. Okay. And I'm going to just take this blink command and I'm just going to cut it and put it here. Okay. Now, instead of delay, I'm going to call this, or 200, I'm going to call this delay time. And I'm going to copy this, Control C, Control V here. Now notice the parameters of this function take in delay time and it's reused here and here. And then now in my loop, what am I going to do? I'm going to call blink function. Blink function. In the first instance, I'm going to call it with 1,000. And in the second instance, I'm going to call it with 500. Okay. So let's clean this up. Boop, boop, boop. Okay, let's make sure everything looks good. Yep. And so let's just run through it again. I'm going to control pin 9. I'm going to turn pin 9 as an output. I'm going to go into the loop. I'm going to call the blink and it's going to do 1,000. So it's going to go here, execute this. Temporarily, this value is 1,000 now. It's going to turn the LED on, wait 1,000 milliseconds, turn the LED off, wait 1,000 milliseconds. I'm done with here. Then it's going to go to line 24, 25, come back to here, do this with 500 milliseconds or half a second, then go back to 26, 27, rinse and repeat back to 21, 22, so on and so forth. Okay, let's run this, start the simulation and see if it does what we expect. Okay, so there's the slow blink and then the fast blink. Good, and then the slow blink. And let's make it more extreme. Let's do this at 200 and let's do it at 2,000 so you can really see the difference between the two calls. Look at this, 2 seconds, 2 seconds off, and then a blip. Look at that blip, blip. 2 seconds, 2 seconds off, then blip, blip. Good. So this is a way to create a function. Now, how does this tie into the SOS, right? How does this tie into the SOS? What you can do now is instead of call this a blink function, you can do this. You can say void S function. Okay, you don't even have to give it a parameter even. You could just have a bunch of, what do you call it? Digital write high lows, a smattering of high lows. And then you could go void O function, right? You could do it for any letter. And then in here, you could say S function and O function, right? And S function, if that makes sense. Okay, so this would be a way for you to write SOS and reuse this S function code right here. You could do any letter of the alphabet in Morse code. You have all 26 letters, and then now you can just call different functions and have it blink out whatever you want. So I hope this is starting to hit home as to how useful functions are. Okay, great. So this was the task. So we want you to do this. Of course, pause the video, go write your functionalized SOS, okay, and then come back. All right. So let's assume you come back, you got your S function, you got SOS done, brute force. Shouldn't have been a long modification. It should have been pretty easy to put it into SOS functionalized form. And now here we are at the 5th program. Okay, don't disconnect the LED. What we are now going to do is we're going to take in data via a button. Okay, so we are going to install this button here. You have one in your kits, and we have one in the Tinkercad. And this is how it's going to work. You got your button here, and I want you to notice these buttons are there's a slight complication. That is, notice the claw, right? You guys see this claw? Notice B and C are always connected. A and D on the back are always connected. But when you press the button, all of them are shorted together. Okay, so that's just the way it is. Now, this is the circuit diagram for a button. And I want you to think, well, okay, how does that work? So what do we got here? We got the ground and a resistor, and this will be 10K. And then pin 2, you're going to have your button here and then 5 volts. Okay. And so what is this doing? Well, let's imagine if the button is open, what's happening? The voltage at pin 2 is essentially the voltage at the ground because there's no current flowing. So we have a grounded situation. So 2 would actually read low. When I push the button down, what happens? Pin 2 actually is directly connected to the 5 volts, and this resistor now supports that 5 volts. When I release the button, what happens? The energy or charge that was put onto pin 2 now dissipates and dumps through the ground, and this pin 2 actually turns off. So this is a way to give a signal into Arduino. What we call this is the pull down resistor. Now you can invert the logic and create a pull up resistor, but right now this is a pull down resistor, okay? So if I don't press the button, pin 2 is going to see a low voltage. If I press the button, pin 2 is going to see a high voltage. Okay, I hope that's pretty clear from the circuit. With a pull-up resistor, it would be inverted logic. Okay, all right. So what are we going to do? What we want to do is get this button in here. Don't disconnect the LED, and we want to go to File Examples Digital Button. Okay, so let's go over here. You can save your SOS programs, right? Go and save this as a different thing and make a copy. So for example, let's say you got your SOS program. Let's see how we can do this. I could call this program, let's say SOS, right? So I save that as SOS. And let's go back to Tinkercad. Okay, so I have my SOS, and what you could do is you could duplicate this, right? So you could duplicate this. So you have something like this, give it a minute. Okay, so now I have a copy of SOS, and I could say program 5, something like that, okay? So that way, if you need to go back, you can go back. So if I have my code here, I want to go to button. Now the problem with Tinkercad is it doesn't have all the examples as accessible as the main sketch mode. So here, what you do is just do a copy paste. File, examples, what is it? Digital and button. Okay, file, examples, digital and button. And what it does is it opens up this guy here. Okay, and what I'm going to do is I'm going to Control A, and I'm going to Control C, and I'm going to just write over this Control V. Okay. All right. So this code here, we can ignore this for now. What it does is it takes in a button information, button data, and then uses the LED bit built in. So what I want you to do is change LED built in to pin 9, okay? Because we have our LED connected to pin 9. And let's read the code before we connect up everything. It's going to set a button state to 0. It's going to set my LED pin to output. It's going to set my button pin, in this case, pin 2, to input. Notice the difference here. And then it's pretty straightforward. It's going to read the button. Remember that quadrant, digital read pin 2, or button pin in this case, and it's going to set the state. And then I have an if statement, right? And what it's going to say is, if my button state is high, turn the LED on. Otherwise, or else, turn the LED off. I hope it's pretty easy to see this, how this is operating. Okay, so now let's just go into the weeds here. Notice for my if syntax, I have 2 parentheses here, and I have equals equals. Notice here I have equals, I notice here I have equals equals. Equals equals is what we call a comparison. It's asking, is the right equal to the left? Whereas equals, a single equals is assignment. It's saying whatever the right is, set it to the left. Okay, do you see the difference? So common mistake by a lot of students, they put an equal sign here, a single one instead of a double one. All right, okay. So right now we don't have any button connected. We have the code in, but no button connected. And don't forget, you've changed this LED built in to pin 9. The LED built in is typically pin 13 for the Uno. Okay, so I'm going to close the code and I'm going to put in a button. Oh, nice. The button is right there. So I'm going to put this button right here. Okay. And right now, these are shorted, but when I push the button, then these 2 rows will be shorted. Okay, we need our pull down resistor. So I'm going to take this resistor. I'm going to make it 10K. And what's nice, Arduino automatically changes the colors for you, so you never have to remember the color code. And then we can put it here, boom. And what do we have to do? Let's double check our circuit diagram. That resistor goes to ground. Fantastic. So right now I can take a line from ground and just dump it right there. Boom. This line here goes to pin 2. So I can go here, click boom, boom, boom. Perfect. And then my little OCDness, I need to, yes, perfect, yes, okay. Oh, no, it's not, there we go, much better. Okay, pin 2, and then the last one is this part goes to 5 volts, okay? So let me review, ground, 10K, to the button and pin 2, good, and then from the other side of the button to 5. So right now, pin 2 is sitting at 0 volts. When I hit the button, it'll go to 5 volts, perfect. Okay, so let's start this simulation. And if I go again, look at the code, notice the LED is off because the button state is reading 0. I haven't pushed the button. Well, once I push the button, this is going to go to high, and then this is going to trigger high. And so we're going to execute this portion of the if statement. Right now, what's going on because it's low is button state is reading 0. It's asking, is it high? No. So it executes the else. That makes sense. So let's try it. Oh, nice. If I hold the button down, the LED turns on. If I release, the button turns off. This is beautiful. Okay. All right. So now, hopefully, you guys can go and get this button working. And let's see what's the next part of this code. Okay. We have now completed the lab, and you guys now get to move on to your assignment. What you guys get to do is write pseudocode first. And what you want to do is you want to write a program so when you turn on the program, the LED is off. And when you press the button, the LED will blink your first name in Morse code. When your name is done blinking, and if you're, and I think I need to change a little bit of this grammar. If the button is not to press, the LED will shut off, okay? And then if you press the button again, your name will blink again. And use a function for each letter, okay? So you're gonna bring this to lab next week. You're gonna submit your pseudocode code and a YouTube link verbally explaining your working system. And just for funsies, this is your table for Morse code. So what do we notice? If you want a dot, you have E, right? If you want a dash, you have T, right? And then if you want an M, you have, I believe it's a dash dash for M. Whereas an O, look at this. You go down the tree, dash 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 for O, and that's what we know as O. Dot 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 dash 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 dot dot dot. Look at the S. Dot dot dot. So that's S. How do you make H? Dot 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 dot. Ah. How do you make a D? Dash dot dot. So if your name was Dan, what would you have? You would see Morse code would be dash dot dot, then it would be dot dash, and then it would be dash dot. That would be Dan. Oh, nice. Okay. And then they even have these other ones, letter or number, sorry, and then plus equals slash. Okay. So this is a beautiful chart showing you how to generate Morse code for your name. Okay. But yeah, I think you have now learned what an Arduino is, kind of the 4 quadrants of how to take in data, the basic interface, how to connect an LED. We've talked about functions and buttons. So I hope this was informative, and I'll see you at the next lab. Okay, have a great day.